Okay, so last one on the angle series. So let's go with my terrible analogy, not analogy, sorry, my terrible acronym again, or initialism. Kurt, Captain James D. So, do we see a kite? Yes, I do see a kite. If I was to draw a line from the center to the edge there, that is going to give me a kite, which means that this angle is 90 degrees, this angle is 90 degrees, and the whole shape, the interior angles are going to add up to 360. So if I was able to work out this angle, I could then work out that angle, because I know three angles in the triangle. How could I possibly then work out this one? Well, if this angle from here to here is 143, this whole bit has to be 180. So this has to be 37 degrees in here. If that's 37, this also has to be 37 because this is symmetrical down, down the middle. That is all symmetrical. So on this side is reflected. So there's 37, so that's 37. So if I add them together, that's going to give me what? 60, 74 degrees. So if I add them together, I've got 74 degrees. This whole thing has to add up to 180. So I'll say, right, 180 take away 74. That's going to give me 106 degrees in the middle in here. So 106 degrees. I'm just going to at this point take that off because it looks like I'm splitting it, which I'm not. This bit is 106 degrees. So 106. This bit here. Nice one. Which means that this whole thing is 360. I would say 360 degrees. Take away my two 90s, which are 180. Take away this, and then take away 106. It's going to give me my final answer. That's going to come out as 74 degrees to be over. So that's just using the kite rule actually that I've managed to solve this one. But you see the kite involves not the tangent rule. So yeah, I could do it that way. I'll try another way though, just to show you different rules. So say we didn't spot that that was a kite. There's no isosceles triangles, although I could make an isosceles triangle down here. There's a radius, there's a radius. So that's the same as that. But there's no angles down there, so it's not very helpful just now. There's no right angles as well because there's the diameter. I don't see any lines coming off, so I can't use that. All I've got really is the tangent rule. All I know is that this is 90 degrees just now. So this makes you think I'm maybe going to have to use my other skills, my kind of first, second year skills, right? So I've got 143 in a straight line. So now it's going to come out as 37 in here. Okay. I've also got two parallel lines. If we're just now rub that out, I've got two parallel lines. I can then, or I should then be thinking about Z rules and F rules. So there's a Z shape. Yeah, there's my Z. So if that's 37, this is also 37 degrees. I just said that this was 90. That means that this is 37 and this angle in here is going to be 90 take away 37. That's going to come out as 53, 80, 10, 53. And then you would say, okay, well, I know that these two tangents, where they meet the circle, it has to be symmetrical because, like we said, this is it's like a kite. So that's 53 degrees, that's 53 degrees. They add up to 106. Angles in a triangle add up to 180. So that's going to be 74 degrees over here. So knowing that your tangents meet at the same points, it's symmetrical down this middle line, is important knowledge here. So you knew when you got your 53, well, I know that's 53 as well. And then you can get your 74. So this way you were using almost all your old skills, the tangent rule as well, but there was more straight line and Z rules. I think that's quite a tricky question, that one. But yeah, two different ways to solve it. It's not always just one way. I kind of prefer solving it that way, but it's me. We'll do this one. Yeah, we'll just this one touch on that one. Then that's us done. So BDF. So let's just draw in then B. Where's B? Okay, there's B. There's D, and there's F. So this wants us to work out this in here. This so two angles effectively. So everything that's written down is on the diagram. Let's just go through our chart. Do I see a kite? No. Do I see isosceles triangles? Yes, I do. There's a radius, which means that that angle is the same as that angle. At this point, I'm just going to change the color. Okay, yep, and I know that that's also a radius, so I know that that is the same as that. And like I said, it's like you can draw little arrows to kind of help show which angles are the same. So it's not the center one and this one, it's the two edge ones. So that's quite helpful. Do I see a right angle? Yes, I do. There's a right angle because this is a diameter and this forms a right angle triangle when these two ends touch the circumference. That's good. And do I see a tangent? Yes, I do, which means that that is also a right angle. That's me going through all my rules. Now we'll just do some angle chasing. Okay, so I'll zoom in a little bit. Nice. So if this is 90, the whole thing's 90 and that's 77, then this is going to be 13 because that has to add up to 90. So that's 80 and 90. Yep. There's your right angle. That whole thing adds up to that. That's 13. That's 13. So we go, I'm halfway to solving it. The only one I need to get is this one now because I'm trying to get this whole angle. I'm so close. Right, so what else can I work out? Okay, well, I know also, should have really said, sorry, that is also 90 degrees, isn't it? So does that help me any? Not really. So this isn't looking particularly helpful in here. So what else? I've got the 64 and that. Okay, there we go. So 64. This is 90. Angles in a triangle add up to 180. So over here is going to be 26. I'm just going to write that in the color. And a different one. I'm going to say that's 26 degrees because this is a right angle triangle. 60, 20, 80. Yeah, that all has to add up to 180. So our final answer is going to be, okay, well, angle BDF is equal to 26 degrees plus 13 degrees. So that's going to be equal to 39 degrees. So again, it looks quite intimidating, but you've just got to try and break it down and sketch what you can and demonstrate as much as you can. Now, actually, I've been a wee bit lazy on these videos and not really showing a huge amount of working. I've tried to do a little bit, but really when you do it, show as much working as you can on the side of the page in case you make a little arithmetic error. Even if you want to write down, you could label it up. This is the tangent rule, and but show the marker as much as you possibly can. And the very last one, I'll see if we get through all of it. If I get a cut off, I'm not fussed. I just want to go through one main bit. The minute you see, and again, I'll maybe add this to the top actually. The minute you see a shape, just put it in blue. You see a shape, I'm going to call it around a point. You should be thinking angles around a point. So if you get something like this and it's all even, you know that this has to add up to 360 degrees. Okay. Again, it's kind of an older skill. But angles around a point add up to 360. So you should be thinking, okay, well this all adds up to 360 degrees. I have got 10 slices all coming in. So that means that each one is 36 degrees. They're all 36 degrees. And I'm only going to write it in these two because that's the ones that I'm concerned with because I'm trying to get into this shape here. So if that's 36 degrees, how would I work out the edge ones? Well, let's do 180 take away 36 first of all. I'll just borrow from that. So 10 take away 6, 4, 7 take 4, that's 144. So these two angles have to add up to 144. So I'll say, okay, and then half them, don't I? So 2 into 1 is 0, 2 into 14 is 7, and 2. So that's 72, that's 72, and that's 72. So that's a nice start. You've identified your point around the circle, and now you know the edge sections. You get a mark for that. Now I need to get into this triangle. How can I possibly work out this angle? Well, angles in a straight line add to 180. So I'm going to say that 72 plus 72 is 144, and 180 take away 144 is 36. This angle, therefore, is going to be 180 take away 36 plus 17. 36 plus 17. 7 and 6 is 13. That's 5. So take away 53. I have to borrow 7 and 1. That'll give me 7, 2 and 1. So it's 127 degrees. Now I've just tried it, I'm trying to show my work and do it a bit neater than that, obviously. But I think if I was in an exam, I would maybe label it off like this and show some kind of neat working. And you can even write what you're thinking, right? The rule you're using. Round a point add up to 180. Therefore, just if you make it nice and neat, so a marker knows what you're doing. I'm just trying to demonstrate how you do the question. I should probably really replicate what you do in your exam. Apologies, but yeah, just to try and give you a sense of how you would work around these questions because I know it can be quite hard. So yeah, that is the angle section done. Make sure you remember your Kurt